Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. It's studying conic sections, and we're going to continue talking about parabolas. All right, well, what's a conic section? As I already mentioned in a previous video, we're going to slice through these cone shapes here, and some intersection points, interesting curves show up. This first one is parabolas, so let's get a focus on that. A parabola is going to be a U-shape or an upside-down U-shape where you have a vertex, which is either the lowest point on a U-shape or the highest point on an upside-down parabola. And right through the middle there is a line of symmetry. It's a symmetrical shape because the curve going out to the right is exactly the same curve as going out to the left. That's important to know when we're trying to graph these things. And again, we talked about the formula or the equation structure of a parabola where we have an a constant on the outside and we have an x minus h quantity that's being squared and then a number, either positive or negative, on the outside. Now, if we have it in this structure here, sometimes we have to, by the way, take an equation and rewrite it in this form. Then I can identify the h and the k, which is the vertex. So again, in the previous video, I showed how the usual parabola shape is in blue. This is kind of in the home position, vertex at 0, 0 in the origin. But if we start putting in h and k values there, then we have some shifting right and left or up and down. All right? So in this case, we shifted 7 to the left and 4 down, and that's why the vertex looks like that. So to draw a parabola, we need to know the vertex, we need to figure out the line of symmetry so that we can start plotting some points on either side. And the y-intercept is sometimes valuable so we know where it crosses that y-axis. All right, now I want to talk about this a value, which is the constant, the multiplying constant in front. Okay, what it does is, depending on the value of a, it's either going to pinch the legs of the parabola closer together or stretch them out and make it a flatter looking shape. So let's go to a graphing calculator. I want to show you how this works. All right, this is a graphing calculator, and it is among many that are online. I'm going to go ahead and start with a red function here, and I'm going to type in x squared. So that's a typical parabola shape. Let's look at the graph. There you go. Okay, so that's in red, and notice how it goes over 1, up 1, over 2, up 4, and over 3 up 9, which is actually off of my graph. All right, let's do some multiplication here. Let's put an a value in front of 2. So it's going to be 2 times x squared. Now that's the way it's going to look. We have to put a caret in here because we can't type in exponents. But that's 2x squared. What's that look like? The original is the red color, and now with a 2 multiplier, it's pinching closer together. All right, back to the equations. Let's say 4, so it's going to be 4 times x squared. All right, see how it looks? Let's look at the graph. Oh yes, so that purple is pinched in even more. So starting with red, as we have a value of 2 or 4, notice how it pinches in closer and closer. So how do we flatten out the graph? Well, let's put a value that is less than 1, and let's say 0.5. So let's go 0.5 times x squared, okay, or 1/2 x squared. What happens? That's green. It's flattening out, isn't it? All right, let's look at another one. Let's say 0.1. 0.1 times x squared. Let's look at the graph. It's really flat because the a value is getting smaller. All right, well, what if it's a negative number? Let's say y equals -4 times x squared. All right, so in purple I have positive 4x squared, and in this teal color I have negative 4x squared. Let's take a look. It's flipped over. So look at purple and look at teal. There you go. Mirror images of each other. So a negative coefficient, or a value, flips it down so it's an upside down u. All right, we're going to put this to use in graphing parabolas. All right, as always in these problem set videos, I show you the problem and you pause the video and you try it first. So grab a piece of paper, just kind of sketch it on a piece of paper. You don't necessarily have to have graph paper. And you're going to find the vertex and the axis of symmetry for each and sketch the graph. Go ahead. All right, number one, remember that the formula for the parabola, the equation of the parabola, has to be x minus something, okay? The h value is the negative part, and so that would have to be a -1. All right, and that's why the vertex is at a -1 there. And the number outside, including the sign, is the k. So the h comma k vertex is going to be -1, +3. And there you go. So we locate that first. And you notice how there's a 1 as the a coefficient there. In other words, it's going to be a regular looking parabola. So from the vertex, we're going to go over 1, up 1, over 2, up 4. And it looks like we run out of room. So it's symmetrical here by the axis of symmetry. X equals -1, which of course is this. So you find the vertex, and then you note whether this thing is going to be bending at all. And if not, it's going to be 1, 1, 2, 4, 3, 9, and so on. So you can locate the points and sketch it out. All right, finally the y-intercept is important to know so we can be a little more exact. And that means that x is 0. So if we put a 0 right there, it's going to be 1 squared, which is 1. 1 plus 3 is 4. All right, so your y-intercept is going to be 0, 4. And as you can see on the graph, it's going to be right there. All right, so that's the information you need to sketch this graph. Now number 2, don't let the 2/5 throw you here. Let's go ahead and look at it. Notice the 1 there and the 5 there gives you the vertex of 1, 5. So that's why we have the parabola starting right there. And let's go ahead and find the axis of symmetry, which of course is at +1. All right, so we just kind of shifted it over, obviously. Now the 2/5, of course, is going to flatten it out. Remember what I showed you on that graphing calculator. And let's go ahead and find the y-intercept. So if x is 0, that's going to be -1 squared. So that's going to be 2/5 times 1, which is still 1, plus 5. All right, so 5 and 2/5, a little bit over 5, which is right there. So it kind of tells you it's indicating a fairly flat parabola, and it's symmetrical, so we're going to come out on both sides. And that's going to kind of help us draw it out. So again, knowing what we know about the a value being, if it's less than 1, then it starts to flatten out, and that gives us a good idea of that parabola. Let's try 2 more. All right, number 3, we have 1/3 x plus 2 quantity squared plus 4. Locate the vertex, line of symmetry, and the y-intercept. Sketch the graph. And number 4, when you're ready, go ahead. All right, number 3, notice it says x plus 2, and the form of the equation, remember, it requires a negative sign or subtraction. So think of it as x take away -2, and that's why that's the h value right there. And the 4, of course, is positive, and we keep that sign there for the k value. So the vertex is -2, +4, back 2, up 4, there you go. Now again, it's a 1/3, so it's going to be flatter than a normal looking parabola. And let's go ahead and find the axis of symmetry, goes right through that vertex. So again, if you're sketching this graph out, everything is symmetrical about that x equals -2 line. And let's find the y-intercept. Maybe that's going to help us figure out the curve. So the y-intercept, remember, is when x is 0. So if we substitute x is 0 in there, that's just going to be 2 squared, which is 4. 1/3 times 4 is 4/3. And then we add 4. All right, so what is 4 and 4/3? Well, that's another 1 1/3 there, so it'd be 5 and 1/3. So there we go. It looks like it's going to cross right there, and so you can put a mark right there and equally across that line of symmetry right about there, and then you can kind of get an idea of the curve. There you go. Number 3, notice the negative sign right there. That's a negative a value, so it's going to be an upside down parabola. And the vertex is located at 2, -3, as you can see by the h and the k values right there. +2, -3. All right, so there you go. There's your parabola. And 2/7 is smaller than 1, so it's going to be flatter. But let's go ahead, and line of symmetry is 2. So we know that everything's going to be kind of folded or bent around that thing. And then the y-intercept. Let's take a look. Substitute 0 in for x, so that'll be -2 squared, which would be 4. -2/7 times 4. Let's write that out and see what happens. All right, don't forget to subtract 3. Now that would be -8/7 take away 3. -8/7 take away 3. Now -8/7 is a little over 1, -1 actually, right? So it's about -1, -3, that's -4, a little over -4. And a little hard to see here, but basically there you go. And if you can mark that there and get an approximate mark over symmetrically on the other side, now you have a balanced parabola, and that gives you an idea of what it looks like upside down. All right, well, thanks for watching this video. In the next one, we're going to be talking about circles and graphing and finding the basic shape in the equation. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard,